Hello all, and welcome to our webinar today, How to Identify and Resolve Common Problems in Physical Security. Today we have with us Darren Giacomini from BCDVideo. Darren Giacomini is the Director of Advanced Systems Architecture at BCDVideo and has over 16 years of networking experience. Darren holds several certifications and also contributes monthly to Security World as a columnist to share his insights and knowledge on physical security networks and what it takes to deliver the most capable video surveillance network infrastructure. In today's webinar, we will introduce a structured approach to identify and resolve common problems encountered in physical security deployments. This approach will focus on resource saturation or depletion of critical resources at the camera, network, storage, and decoding endpoints. Leveraging a structured methodology to troubleshoot common issues will drive faster resolution to customer problems while decreasing eroding margins due to repeated site visits. My name is Julie Rolls. I am the training manager at PSA, and I will be facilitating our call today. I have just a few quick housekeeping items before I hand it over to Mr. Giacomini. First, if you've not already done so, please mute yourself. If you happen to have any questions throughout the course of this presentation, please type them into the chat panel and we will have time for Q&A at the end of this presentation. I will also be monitoring chat should you run into any technical difficulties, and I'll do my very best to get you back up and running. With that, I'm going to hand it over to Darren. Welcome, Darren.
Thank you, Julie. Welcome to the presentation. Now, the idea of this presentation is to talk about some of the challenges that integrators face on a regular basis with respects to how to keep projects on track. Everybody's been involved with those projects that you have particular issues that you can't seem to solve or won't go away. And you're repeatedly taking site visits or rolling trucks out to site to try to resolve issues that are either difficult to resolve or can't be resolved working through the vendor itself with respects to their support infrastructure. So if you take a particular scenario, you say like you have a site that is experiencing some type of artifacting or tearing of video or latent PTZ control. And often what will happen is you'll place a call into that vendor for support. The vendor typically will come back at that point and either address the issue or escalate that up through the chain to try to resolve the problem. But more often than not, you find yourself with the following scenario. And most of us who've been in the industry long enough know a little bit about how the blame game works. Let's say that you have a tearing of video or a particular problem that you're experiencing, and that may sit in the support queue for a week or two. If they can't find resolution to the issue, more often than not, it comes back that the problem is not ours. And the response typically is we could not reproduce it in the lab. So it's either infrastructure related or an issue with one of the other vendors that you're dealing with. And so you find yourself stuck in the middle trying to figure out, I have this issue and I'm contacting the vendor that I believe the issue is related to, yet they're saying they can't replicate the issue. So the idea of this presentation is to talk about those common things that you encounter and how do you get past the blame game? How do you get by the situation where vendors are trying to either blame each other for what's going on or can't truly identify the source of the particular issue that you're experiencing? When you take a look at the physical security industry, it's a pretty finite set of things that you're going to see with respect to problems that encounter. You're either going to see people complain or customers complain of degraded video quality. That can be comprised of tiling, pixelization, tearing, could be complete loss of video or blanking out of video and video coming back online. You'll have customers that are still using PTZ that will complain of latent PTZ control, meaning they can't control their cameras or sometimes have runaway PTZ control, where they'll move the camera, yet it keeps moving after they stop the action. We often have customers or complain about delayed access to video, meaning they can't get access to their video or they're waiting too long to get access to either live or archived or recorded footage. Gaps or lapses in video footage, meaning that archived video has gaps or lapses in the coverage, or video that's not being recorded even though it's set in a environment that is continuous record. System instability or devices going on and offline. And then you have database corruption that can categorically either wipe out an entire system or at least wipe out a recorder itself. So these are the common things that we see people complain about, but what's the root cause? In my experience in the industry, almost 95% of what I just talked about is either cabling and infrastructure related or resource related. And when I say resource related, every component that comprises a physical security system has a set of resources associated. It has CPU, memory resources, network resources, and a network buffer, and obviously network cabling and physical cabling attached to that. You're going to have a certain amount of finite storage resources, which different grades of storage can have different capacity and different performance levels. And you can often find yourself with a situation where you have depleted decoding abilities. Either the GPU or the CPU associated with decoding can be overloaded. But those particular resources are found either whole or in its entirety throughout the entire system that we go out and we start troubleshooting. So if you take a look at the first segment that we're going to look at, is you start from the outside in. Whenever you're troubleshooting a scenario and trying to figure out what the associated problem is, you typically start at the source. And the source of video inside a physical security network obviously is going to be the IP cameras or encoders. And the IP cameras or encoders have CPU resources, memory resources, and network resources as well. Given those, the most common or most frequently depleted resource associated with IP cameras is going to be CPU. When you are creating 1080p 30 frames per second images inside of a camera, and you may ask that camera to create 1, 2, 3, or 4 of those images that can be sent out, it's very easy to find yourself in a zone where you're depleting those resources. And in most cases, what we're going to talk about today, 85% is the warning zone that when you get into, you start to have problems above that. So I have an IP camera with a CPU is above 85% utilization. It's going to cause issues when I have microbursts or microspiking. If you have memory that's depleted past the 85th percentile, it can cause issues. Or if your network and network buffers are depleted beyond the 85th percentile, it's going to cause issues. From the camera, then we always turn our focus into the physical cabling. We got to look at the termination quality. Is it terminated to the specifications of the cable? What does it produce with respects to active speed and duplex? A big one, what's the cable length? More often than not, we'll see people exceed cabling lengths. And is there environmental interference? Is this running by a power supply? Is it running over lights, etc.? All of those can lead to problems in the overall chain of how the video flows. From the cable in, the next stop going from the camera to the cable connecting the camera would be the edge or IP camera switch. And this is where the cameras are actually terminating and providing PoE at the edge. CPU performance obviously can be a major performance issue. If your CPU goes above 85%, you are going to start to drop packets or you're going to start to corrupt the video. Switch memory performance, this one's pretty rare. It's not that it can't happen, but it doesn't happen very often. More often than not, if you're seeing depletion of switch memory, you have some kind of firmware or OS version issue on that switch that needs updating. We're going to take a look at IO port statistics, meaning the input-output of the port stats. How many packets are coming in? How many packets are being dropped? How many are being discarded? And are there problems with the overall structure of the packets that would suggest that there could be layer 1 issues? And one of the most common things I see on switches is port buffer depletion. Every switch has a buffer associated with the ports. And as we start to take packets, if the other side can't process those packets fast enough, the buffer will hold those packets until the resource is available to accept them. In lower grade switches where they have smaller port buffers, you can find yourself in a scenario where you're dropping packets because your port buffers are actually depleted. From the edge camera switch in, once again, between each one of the switches, you always want to assess the quality of the cable length associated with it. The termination, active speed duplex, length of the cable, and is there any environmental interference that could be causing problems. From the edge switch, you either have a distribution or you'll move into the core switch assessment. Now, the assessment that we do on an edge switch versus a core switch, for the most part, is going to be very, very similar. The most critical resource is going to be CPU that we want to look at. IO statistics and looking for layer 1 issues and port buffer depletion. But you also could have layer 3 routing and other things that would happen at a core switch that could be assessed on it and may need to be looked at. The last thing you see in the chain is your decoding point. And this is where you've got either the decoder or your workstation. And every workstation or decoder, whether it be Linux-based or whether it be Windows-based, has a finite limitation to its CPU, memory available, NIC speed duplex, NIC stats, and ingress statistics. So what we're gonna do is take a look throughout the process of this, how to go through each one of these devices and determine where they are. Today, for some of them, you may be flying blind. Most people don't see inside their IP camera as far as what's the CPU load. So we're gonna take a look at what is the process that we go through, where do we start, how do we run through this assessment, and more importantly, how do we figure out where the problem is so you can address the appropriate resource. The biggest thing that I see in the industry is when people make calls in for support, more often than not, they're not addressing the correct resource. And if you're not addressing the correct resource, that's going to result in a drawn out process, trying to figure out what's causing the issue and bring in resolution for your customer. So our flow that we're gonna go through is gonna start at the IP camera. It's gonna move to assessing the physical cabling, the termination point and assessment of the IP camera switch, the physical cabling that will connect between the edge camera switch and the core distribution, the cabling between the core distribution and the decoding point, and the decoding point itself. We're going to take a look at how to pull the stats off of each one of those so you can make an educated assessment as to where your problem derives from. So the first thing we're going to look at is IP camera resources. And I can tell you, you may be fighting somewhat of an uphill battle on this to some extent. Not every vendor is going to publish their ability to get into their secure shell or their ability to get into Linux command line. In order to do the assessment on any IP camera, you're going to have to get into Linux shell or have potentially some type of SNMP software running that can give you the statistics. More often than not, if I suspect that I have a camera that's being overloaded, I'm going to find a way to secure cell into that with administrative level access. So in the procedure that I'm going to give you an example for, this is actually just an access camera because it's what I have here in the development lab in Fresno. And online, if you do any Google with respect to SSH into access, it will give you this procedure. If you're running 5501 or later, you can click the link that allows you to edit the SSD file inside of the camera and change it from a no to a yes. At that point, the camera has to be rebooted, and then you can use either PuTTY or traditional SSH from command line if you're on a Linux or a Mac operating system, and you can actually remote directly into that camera. So in order to remote in, you're going to have the administrative credentials or root password and the administrative credentials or the user account. But once you get in, there are some key commands that you can run. In order to assess how a camera is actually operating, number one, it has to be under full load, or at least under a typical load that you're running in your operating environment when you're seeing the issue. Once you're logged into that camera, the top command can be used to give you an assessment with respects to what's the load that's being placed. Now, if you look from left to right in this diagram, you'll see 0.63, 0.58, and 0.32. Those are the 1, 5, and 15-minute averages that you're seeing for the load that's being placed on the camera. That's actually a little bit skewed because if you look below, we can see that we have 2 CPUs associated with this. So 63% being reported in the 1 minute is not necessarily out of one processor, that's across 2. So that load is actually going to be split across 2 and be closer to 30 some odd % utilized. So because of the confusion of the top command, I typically don't do CPU assessment from that, but what you can get from that is the memory used and memory free, plus the buffer being used. So we can get a very good idea of whether we're leaking memory or having memory issues. If you want to look at the CPU, the iostat-c command will actually give you the percentage user, the system, the IO weight steal, and the idle. We can see from here that our camera is 91% idle on its CPU, meaning that we're nowhere near overloading this camera. We're roughly only using about 8% for our operative status. But if you saw that to be in the 85 or 86 percentile, then we'd have something to worry about. From the CPU and memory, the next command you take a look at is the ETH tool, which is the Ethernet tool. And in most cases, the Ethernet interface is going to be called ETH0. What we're looking for with the output from this command is what is the speed or duplex that it's associated with it. If you have a gigabit port on that camera, yet it shows it's only connecting at 100 megabits per second, that's going to be a problem for operation. If you take a look at a 10100 camera or 100 meg and it's connected at 10 meg, that would be a problem. The other thing we'd look for is the duplex. Is it running bidirectional communication at full speed? If it's half duplex, that almost always signifies that you have some type of layer 1 physical cabling issue that you need to deal with. And finally, you can see in there, is the link detected and do we have auto negotiation on? One of the most misunderstood things in this industry is auto negotiation. You have to have auto negotiation on both sides or statically define your speed. You cannot mix the two. You cannot run auto negotiation on your camera and then statically define your speed on your switch, or you're going to have all kinds of problems. Within the NIT statistics we're going to look at, there are typically 4 areas that we're going to look at from the camera perspective. If I see elevation in the number of errors, that almost always tell me that I'm having errors transmitting packets, and 90% of the time it's going to be a speed duplex mismatch, meaning the speed on both sides don't match or the duplex doesn't match in the negotiation. If that is not the issue, then it's probably going to be faulty cabling. So if I see elevated numbers and errors, I always look at speed duplex or I look at the actual cabling itself. If I see elevation in drop packets, 90% of the time, it means that you're overloading that particular device. You're trying to push too many packets through it or more packets than the actual network interface can process. And that's going to result in drop packets that you can't transmit that then would result in loss of data across the video itself. Anything in overruns would mean that the buffer associated with that network card is being overrun, meaning that the buffer's filling up, causing latency in delivering video. And finally, you can take a look at carrier, indicates how many times that link may have gone up or gone down. So to get those statistics, which are absolutely critical, you can do the IP-S link command inside of the camera. And I've highlighted the things that you want to look at. You want to make sure you get the right interface, which is ETH0, and then you'll see two sides here that we're looking at. Receive RX and transmit TX. Now you can see in this diagram that I have 5,607 drop packets on the receive side. That's probably not a concerning thing in the millions of packets that you can see I've transmitted on the left. And the reason I say that is it's on the inbound receive side. If I'm dropping packets on the receive side, it's because it's traffic that wasn't intended to be processed by the camera. If I were to see these packets elevated on the drop side for transmission, that would be a warning sign. So typically I look for errors, drops, carrier advancement, or collisions. Any of those numbers advancing on the camera on the TX side mean that you have a packet loss issue that could be associated with resource depletion of the camera, the NIC, the network buffer, or potentially have bad cabling connecting it. When you're done assessing the actual camera switch itself, the next thing would be obviously to assess the cabling. Hopefully your cabling has been certified, but then you're going to take a look at the IP edge camera switch. And in order to do that, you're going to have either SSH or Telnet connectivity or console access locally. You're going to need the credentials. In some cases, you can get into the web access for the switch. In some cases, you're going to have to use command line. And in other cases, they may have a network management system that can actually deliver this, from a web interface that you can actually perform your analysis. The most important thing with both the IP cameras and the switches is know your limitations. How far should you really be going? If you're not familiar with command line, you may want to find somebody who is familiar with it to do this. This is an example of an NMS platform or a network management platform that could deliver those statistics, specifically this one being from Alcatel-Lucent. And Alcatel-Lucent is the switching platform that I'm actually going to use and that we use within our lab to actually do this analysis on. The first resource you always want to look at inside of a switch is the CPU. And the same numbers with respects to cameras applies to CPU in switches. Anything above 85% is going to provide instability. So in this particular instance, if I take a look at the Alcatel output, I can do the show health all CPU command, which will actually give me the current CPU utilization, 1 minute, 1 hour, and 1 day averages that I see for that switch. If any of those elevate above that 85th percentile, it's going to require that I need to do further investigation, meaning that I've saturated the resources. The show health command below in general will deliver the exact same information, but also deliver it for the memory. So as I said, memory depletion in a switch is very rare, but it can happen based upon code having a memory leak. So in this particular instance, we can see that it's pretty steady at 15%, well below 85%. There is no either CPU or memory related issue. Checking the speed and duplex. So we checked the speed and duplex on the camera, meaning that the cameras was at 1000 full duplex. In this case, we'd run the show interfaces status command, which for each individual port will show us what's the speed capability, what's it connecting at, and is it full duplex. Now this particular command I ran on a 10 gig switch, so the output's a little bit different, but you always want to look to see that A, you're set for the same type of negotiation or static implementation of the speed and duplex, and B, that the speed and duplex matches what you see on the camera. And that can all be derived from these status commands. An individual interface can be assessed as well. So in this case, if I had a camera connected to interface number 1, I could run the show interfaces command, and then I've highlighted what you look at here. And it's, once again, it's broken down into receive and transmit. Any incrementing in large numbers here for what I've highlighted for CRCs, lost frames, error, alignment errors, collisions, any of those that go elevated above, say, 8 to 10, more than likely you have some type of physical cabling issue that needs to be addressed. Now, I always tell people with these, once you look at these statistics, you need to clear them. And the reason being is these have probably been implemented since the switch was powered on and it was deployed. And a lot of times during deployment, you'll see these numbers elevate. So clear the statistics, execute a reanalysis. If you see any of these numbers on the port elevated, more than likely you have some physical cabling issues, or you have some type of infrastructure related issue with the layer 1 connectivity. This is actually my favorite command inside the Alcatel line because it's human readable. If I do Cisco or HP or other vendors out there, it's very difficult to tell when I've reached a point of resource saturation. When I say that it's human readable for Alcatel, this is telling me for port 111, currently I have no traffic, so all of the amounts are 0. The limit's set to 80% to give a warning, but this is telling me for receive and transmit what percentage I'm using of my capabilities. So if I'm funneling 800 megs of traffic through a gig link, and I'm showing 85% saturation or 85% of the transmit, that's above where I should be. But I can run this command very quickly to tell where I'm at with respects to both inbound and outbound traffic for a port, and do I need a faster port to actually send that traffic across. If you did find yourself where you had some layer 1 issues in either speed or duplex, or you had elevated statistics, there is a really cool command built into the Alcatel Lucent packet or command line that allows you to actually run time domain reflectometry, meaning that you can actually run a TDR and tell whether you're passing cabling standards and what the lengths are. So if you see an increase in errors or statistics, this is a great command to use to see what the length is and see whether or not it's passing the cabling standards that you've wired it for. All of those things I just went over, you would go through each switch in the network from edge to distribution to core in the path or chain of data flow where the video goes from camera into decoding point. So you basically would rinse and repeat. The last thing you look at is the decoding point. And once you're in the workstation, you can hit Control-Alt-Delete, Task Manager, and hit the Performance tab. Quickly inside of Windows, you can get the CPU, memory. You can look at the amount of data coming on your Ethernet. If you've got multiple Ethernets, such as in this case, you can look at both inbound and outbound traffic and get a quick snapshot. If you are running GPU decoding, it will also show up here as well. So the key critical thing on the decoding point is always going to be CPU and GPU levels. Anything above 85% is going to be extremely problematic and cause issues. If you want to assess the network and what it's doing itself to see if you're actually dropping packets or the network card is overloaded on the workstation, you can run from command line the netstat-e command. In this case, you can see how many packets I've received, how many packets I've sent. What I'm looking for is if I'm discarding packets on the receiver sent side or if I have any errors. So in this case, I have neither, meaning I have a healthy network buffer and a healthy network card. But once again, this is another point that could be saturated and cause packet loss that would degrade the video quality. If you want to add in the disk performance itself, and in general, you want your disk performance with respects to latency to be somewhere below 200 milliseconds of read-write. If you want to add the read-write to the actual task manager so you can view that, in Windows, it is a command that you have to execute. So from command line, if you execute diskperf/y, it actually will add that into your task manager. And so I execute this command, and you can see that I've now added the disk performance stats to task manager as well, allowing me to peer into what I have going on with disk IO and determine if I have disk IO problems. Traditionally, you'd be doing this on an archiver or something that has a large amount of read or write going to or from the drives. So I know this is a high-speed passover, and this is really kind of warp speed that we went through this. The idea is we wanted to introduce this concept to everybody, and the train of thought is to submit this to an PSA next year for a follow-up to do an actual in-person presentation, where obviously we have more time than 30 minutes to talk about it. But I did want to get the tools out there. So if people want to go through this and start trying to leveraging some of these tools, this systematic approach to figuring out whether your bottlenecks are can really get you out of these projects that you can't get out of, that you're repeatedly having to go back to. And it can allow you to define where the point is or where the saturation is. So you're calling the right resources. You're calling the camera vendor or the VMS vendor, or you're calling your storage vendor. In the absence of taking this type of approach, typically your first call is going to go to the VMS vendor, and if they can't replicate the problem, you're going to kind of go to the finger pointing game. And as I said, it's a lot to take in. It's like drinking, water from a fire hose, but I wanted to at least get it out there so that we could set this up for a follow-up session that we'll do later on in person. So at that point, I'll open it up if there are any questions.
Well, thank you, Darren. This has been very informative. I had a question myself, just out of curiosity. What are the biggest challenges that you see integrators encounter, or specific issues that you've seen?
Honestly, the toughest thing is with all of these multifocal cameras and with multiple lenses in them, the CPUs are running very hot to stitch all that video together. And being completely blind to what's going on inside of that IP camera, you're really taking the vendor's word that it's not running to the performance maximum that it already can, or it's not running right on the bleeding edge. So more often than not, when there is a firmware issue or there is a resource saturation in the camera, it's completely blind. And I would say second, I would follow that up with physical cabling. The physical cabling is often not certified, which you're going to see all of these things elevate if the cable's not certified. If you don't have a known good road, it really doesn't matter what car you buy to drive on it.
Good point. Good point. No, that looks like all the questions that we really got today. But I did want to mention to everybody that BCD will have a virtual booth during ADAPT 2020 coming up here in just a couple weeks. So if you have more questions for Darren, you can either ask him then or reach out to him here with his contact information posted. You can also find this recording that we'll have posted soon by visiting psaeducation.com. I want to thank Darren Giacomini and the entire BCDVideo team. As I mentioned before, Darren's contact information is posted here if you have any more questions today. Please visit our website, that's psaeducation.com, to be sure that you're leveraging all that PSA has to offer. On our education page, you can access our future webinar events, this recording, our educational offerings, and our business solution providers. This will conclude our presentation for today. I hope everybody has a wonderful day. Stay healthy and stay safe.